So let's go and have a look at another right angle triangle to have a go at here. We've drawn a right angle triangle where the height is 1 unit and. Well, that's a fabulous bit of grammar there, David, well done. And the hypotenuse is 2 units. Use trigonometry, find the angles in between. Okie dokie. So we're going to label that as 1 and label this as 2 units. We should also find out what that other side is. Now, how on earth could I do that? Well, easiest way to do that, of course, is to use Pythagoras. So to find that lovely missing side, I know that c squared, let me write that clearer, c squared is equal to a squared plus b squared. And if I label that as a, b, and c, to find out that missing side b, I'll do c squared take away a squared is equal to b squared. So in this case, 2 squared minus 1 squared is equal to b squared. 2 squared is 4. 1 squared is 1. And so therefore b is equal to the square root of 4 take away 1. 4 take away 1 is 3. So the square root of 3 is this distance here. So square root of 3 units. Now, with maths methods, we always like to use the exact values where possible. So you don't need to go to the calculator and go however many decimal places. Just leave it as square root 3. Let's say we're going to find the angle for dangle down here. So I'm going to label that with a little theta. So we can know that sine of theta is equal to the opposite over hypotenuse. So the opposite here, so is A, and then the hypotenuse there is C. So this is equal to 1/2. So in my calculator, I need to go and find what is that angle. So what I do is a thing called the inverse sine. So the inverse sine looks something like this. It has a little to the power of -1, that is an inverse, 1 over sine, if you like. And I just need to put in that answer of 1/2, and that will tell me what the angle is. So if I go into my calculator, I'm just going to use the trusty old Microsoft Surface calculator here. And I'm going to type in 1/2. Of course, it's 0.5. Keeping this in degrees for the moment, yep. So in trigonometry, what I'm going to do is you'll see all my little trigonometric, trying saying that when you're drunk, trigonometric functions have all come up here. I'm going to press second, and then what I'm going to do is I'm going to do inverse sine of 0.5. And there we go, it's come up with 30 degrees. So this is equal to 30 degrees. Go. Now, we can solve the other angle quite simply from here. We can do 180 take away 90 take away 30. And that will tell me what that other angle is. How did I know that? Because the total angles add up to 180 degrees. And so if I minus those two other angles, because that square, remember, represents 90 degrees. And if I take that away, I'll know what the other is. But for funsies, let's do another trigonometric equation to work this one out. So we'll use cos for this instance. I will label this one here. Let's give this another Greek letter. We'll use beta for this one. So cos beta, cos is equal to adjacent over hypotenuse. So this is equal to A over C. And once again, this is equal to 1/2. So I will go and do the inverse cos of 1/2. And this will tell me what B is equal to. And so this, if I do 0.5, go to the trigonometric section, go second, inverse cos, and there it is, 60 degrees. So that little top corner will become 60 degrees. You could also have done the same with an inverse tan as well, just to confirm if I wanted to do an inverse tan of that green bottom angle there, the one that says 30 degrees, opposite over adjacent. So if I did, because remember that's what tan is equal to, so opposite over adjacent, this case would be 1 divided by, in this case, the square root of 3. So what I'm going to do here is I'm going to go and press 3, and I'm going to write to the power of 0.5, like so. And it gets me 0.5777. 3 to the power of 0.5 or 3 to the power of 1/2 is the same as writing the square root of 3. And I'll click on trigonometry, go to second, go to tan, and there it is, 30 degrees. So we can use trigonometry to find these particular angles out. Find the value of the pronumeral in each of the following. So here we've got 50 degrees. We need to find a side. So this is the x here. I would start by labeling this as the adjacent. This is the hypotenuse. So adjacents and hypotenuses involve a cosine here. So that's what we're going to do. We're going to put cos of 50 degrees is equal to adjacent over hypotenuse. So therefore, using some algebra here, I'm just going to times both sides by 10. And then what I get is 10 times cos of 50 degrees will be equal to x. And so that is going to be equal to, let's bring up our calculator here. And 50 cos. And then we're going to times that by 10. And there we go, we've got 6.428. How many? We may as well just do it to one decimal place here, so 6.4 units, because it doesn't say what the measurement is. This time we have an unknown angle, so we need to find out what this angle is. So this side is the opposite, this side is the adjacent, so we're going to have to do a tangent, an inverse tangent. So tan of the angle is equal to opposite over adjacent. So this is going to equal to 6 over 5. Therefore, the inverse tangent is going to be equal to 6 divided by 5, and we'll go to trigonometry, second, tan, and we get 50.19 degrees. And now we're to find this side. We've got 20 degrees, we've got an opposite to that 20 degrees, and a hypotenuse. Now, when you're labeling these sides, and you're thinking, well, hang on, that technically speaking could be the adjacent to the angle that hasn't got a number inside it. Yes, I know, but generally when we're working for a trigonometry question, we want to be efficient. So if we've been given an angle like this, let's just go and make reference to this. In this case, we're going opposite of a hypotenuse, so this is a sine. So sine of 20 degrees is equal to the opposite over hypotenuse. We're going to times both sides by 10. By 10 again, times sine 20 degrees is equal to x. Put this in the calculator, and we get 20, the sine of that, times that by 10, and we get 3.4.